So good morning, and thanks for your interest in this week's seminar on our virtual tour of S.I.T.E. Hopefully everyone's healthy and making the best of these COVID days. Anyways, my name's Todd Breezewell. I'm one of the product managers at Senstar, which is a world leader in video management and perimeter intrusion detection solutions. With me, I'd like to introduce Stuart Dewar, he's also a product manager at Senstar, and he'll be giving the seminar today. So without further ado, I'll turn things over to Stuart, who will keep you mildly entertained for at least the next 30 minutes or so. So take it away, Stuart.
So thank you, Todd. And as Todd said, today we'll give you a virtual tour of our test site in Ottawa, and also run through some product demonstrations. So here's a shot of actually Senstar and our test site. Here's us here in our building in Ottawa, Canada. And here is our test site located quite nearby. So this is what we're going to walk through as part of this webinar. And here's the agenda we're going to follow about Senstar. There's the tour, the product demonstrations, and Q&A at the end of it, as we said. So first of all, a little bit about Senstar. When it comes to experience in perimeter security systems and VMS, Senstar is really the leader in the pack. So we have now intelligent video management, video analytics incorporated into that package. We have access control with our Symphony, and of course the innovative perimeter intrusion detection systems that are the primary focus of the tour that we're going to give today. Basic facts about Senstar. When it comes to perimeter intrusion detection systems, we're now up to over 45 years of experience in that business, so a tremendous amount of track record and mileage, so to speak. Over 50,000 kilometers worth of installed sensors, a worldwide service and support network, and our large test site that we're going to be talking about. When it comes to VMS, we now have 18 years of that through our acquisition of Imatis, 25,000 VMS deployments worldwide, and leader in intelligent video management solutions for efficiency and scalability. Basic facts about Senstar, headquartered in Ottawa, Ontario, Canada. You've got the video shot of that just before. In Ottawa, we have our manufacturing facility. We have our video and SMS product center in Waterloo, Ontario, Canada. Back in Ottawa, again, we have our product development center for the sensors and headquarters staff. And then around the world, we have numerous sales and support centers, Canada, USA, Mexico, Brazil. The list is there. Products deployed at tens of thousands of sites in now over 100 countries around the world. And of particular note, economically strong, good balance sheet, well established. So if a customer commits to a Senstar solution, you can have trust that Senstar will be here next year, the year after, and 10 years into the future to support and service that installation. Industry experience, our sensors and video management system is used in a wide range of industries. Transportation is represented by the airport here, electric utilities, corrections, lots of experience in the correctional environments where perimeter security is of the utmost importance. Logistics and distribution centers and the factories, important. And again, in the electrical area, power plants, and in particular, the nuclear power plants are a very strong segment for Senstar, and borders. So lots of industry experience all around. Now we're going to do the site tour part, and due to the risks and hazards associated with trying to do this live and putting people through all the gaffes that happen inevitably, we're going to go into a short a 10-minute pre-recorded site tour. So I'll be your virtual tour guide as we do that. Hello, I'm Stuart Dewar, and today I'm going to take you on a tour of Senstar's product test area. I'm standing in front of Senstar's Ottawa headquarters, where we have our sensor engineering group, manufacturing department, and our headquarters staff. When Senstar was founded in 1981, one of the deciding factors in determining the location of the company was access to a large outdoor area for testing the buried RF cable system that the company was developing at that time. The company has grown tremendously since then, and our test area has grown along with it. So now we believe we have the largest privately owned outdoor test area devoted to the development and testing of perimeter intrusion detection products anywhere in the world. So come on, let's go for a quick walk to the test site. So here we are at the front entrance to the test area, and as you can see from the sign beside me, we've crafted a nifty acronym for the site. We call it the Sensor Integrated Test Environment, S.I.T.E for short, and that's what I'll be calling it from now on. So from this vantage point, you get a good look at the scope of the test area. The boundary of the area is defined by the perimeter fences that you see. And in this area, plus some area you have across the road, it totals up to 10 acres of test area, or 4 hectares for those familiar with the metric system. Outside the boundary fences that you see is farmland. And we have good relations with our neighbors, so we can do testing in that area as well. And we commonly do that with our fiber-controlled buried fiber optic sensor. Ottawa is a great place to have an outdoor test center because we have a true 4-season climate. In the winter, it's very routine to get down to temperatures below -20 Celsius or -4 on the Fahrenheit scale. And then in summertime, we'll see temperatures routinely in the 30 Celsius or into the 90s on the Fahrenheit scale. When it comes to precipitation, we see the full gamut: snow in the winter, rain in the summer, hail, sleet, fog, and something we get quite a bit here in Ottawa, freezing rain. So our sensors truly get a full exposure to an outdoor environment here at our test center. When you look around site, you'll see a lot of fences and a lot of different kinds of fences. That's because fence sensors are a big part of our portfolio, and it's important to test them to ensure proper operation on different styles of fence. You'll also see lots of LM100 luminaires installed. We have hundreds of them installed around the site to monitor their reliability and their performance. You'll also see microwaves, single, double stack, and triple stack units. What you won't see is our buried systems, our OmniTrax buried RF cable system or our fiber patrol buried fiber system. They're buried out of sight, and we'll use a digital overlay at some point to give you an idea of where they are in our test site. To monitor the sensor's performance, we have an extensive array of cameras installed that are integrated into our Symphony platform. We collect weather data 24/7 from multiple sensors, and we use a portable weather station that we can put immediately adjacent to a sensor that's under test so that we have close correlation of the sensor performance to the weather. So what actually goes on here at site? 3 things. First of all, this is where we test our products in the development phase. We like to have at least 1 year of exposure in the outdoor environment for our products before we release them to market. Second, we keep all current products installed here so we can monitor their performance and have reference systems in case of support issues. Third, we like to bring customers here so they can get a live view of the sensors in action. However, it's not always possible for customers to make the trip to Ottawa from around the globe, wherever they may be. That's why we wanted to do this virtual tour for that purpose. So let's go look at the fence types and sensors we have installed at site. The fence type we have most of at site is chain link, as shown here. Chain link is very popular in many parts of the world, particularly in North America, but not so much in Europe. Interestingly, in some parts of the United States, chain link fence is known as hurricane fence. Why is it called that? Because it presents little resistance to the wind. And so that after a hurricane goes through, the type of fence most likely to be left standing is hurricane fence or chain link fence, as opposed to, say, other kinds of fences like a wooden fence. That same characteristic of having open construction and presenting little resistance to the wind makes it a great type of fence for mounting a fence sensor. The wind does not move the fence fabric that much compared to the more extreme motions that get created anytime someone attempts to climb the fence. You'll notice on the fence there's a lot of different cables installed. That's because we have a lot of different kinds of fence sensors to test, so we have a lot of cables on the fence. We have cables for our long-range fiber patrol system, our short-range FP400 zone-based fiber system, FlexZone, cables for our older generation products that we're still monitoring, power cables for the LM100, other data communication cables. The good news is that all these cables, all the sensor cables, are fairly lightweight, flexible, so they do not change the characteristics of the fence or stiffen it up in any regard. So we can put on as many cables as we like on the fence to test our wide gamut of sensors. So let's go look at some of the other types of fences and sensors we have installed at site. Here we have a section of weld mesh fence. This is a fairly common style and is particularly common and popular in Europe. So we want to make sure that we test our sensors on it and develop the correct configuration and installation guidelines for it. This type of high fence with a razor ribbon topper is typical of what you'd find in a correctional environment. The important thing here is that we can cover the full height of the fence with a single pass of sensor cable, and that the algorithms we've developed are not unduly affected by the presence of the razor ribbon coils. Facility owners sometimes want a high security fence that has a more polished look than your typical chain link or weld mesh fence, so they may opt for a palisade style fence, such as the one behind me. This is a fairly basic version of a palisade style fence, and they come with a lot of different options, a lot of different topper possibilities, some of them very threatening looking, certainly different heights are available, and they also come with stiffening arrangements so that the fence can be crash rated. But this type that we have here is sufficient for Senstar to test our sensors on and develop the installation techniques and guidelines that we need to provide to our customers. A sensor that has a distinctive look is Senstar's X-Field electrostatic sensor. The system consists of an array of wires oriented in the vertical direction. Some of the wires are active wires and they generate a low free voltage, while others are sense wires and they have a slight charge induced on them by the active wires. When the human body approaches the array of wires, the amount of coupling between the active and the sense wires is changed, and that is the basis for the detection. Although the operating voltage of the system is quite low and absolutely safe, the large insulators do have a rather threatening look, so there is a definite deterrent effect with the system that some of the users of the system appreciate. One of the characteristics of electrostatic systems such as X-Field is that the array of wires can be deployed in configurations up to 20 feet high, creating a detection system that is extremely difficult to defeat using any kind of normal measures. This is one of the reasons that electrostatic sensors, such as Senstar's X-Field system, is a recommended sensor type for the U.S. Nuclear Regulatory Commission Nuclear Guide for Perimeter Intrusion Detection Systems. In the open areas is where we have our buried detection systems installed. Senstar's two buried detection systems are our OmniTrax RF-based system and our Fiber Patrol buried fiber-based system. Now, of course, you can't see them, and that's one of the advantages of buried systems. They're out of sight and covert. Here inside the site trailer, we have the equipment that we use to monitor the performance of our sensors. On the middle screen, we're looking at raw sensor data from one of the Fiber Patrol systems installed here. To show an operator's view of what's happening, we have our StarNet 2 security management system, which provides a graphical map-based display and comprehensive security management features. Finally, over here, we have integrated our sensors with the Symphony platform, which combines video management, video analytics, access control, and map-based alarm display, and gives the security users a single focal point for the operation of their sites. So that includes our tour of site. Thank you for watching. So that's our tour of site, and there's always an open invitation to any potential customers who would like to come and see it live with their own eyes. So that would be always a delight to host customers at the test site. So now we move to the second stage of our webinar today, where we're going to look at some product demonstrations as live as we can make them through the webinar venue. We're going to look at some of our products, not all of them, but we've picked out a selection here. FlexZone, OmniTrax, Xfield, and the Senstar LM100. So first of all, just to warm up for the presentations, what is our FlexZone system? FlexZone system is a fence-mounted intrusion detection system. Uses a specialized coaxial cable that's attached directly to the fence and senses the vibrations of the fence. It not only senses the vibrations and the intrusions, but reports their location to plus or minus 10 feet or 3 meters. System is very cost effective and applicable to the full range of perimeter lengths, from a small electrical substation or gas line compression station to airport scale. Each of the boxes here can cover up to 600 meters or almost 2,000 of sensor cable, and logically the intrusions can be divided into 60 distinct zones for reporting purposes. And not only can the sensor cable sense, but that sensor cable is also used for communications and power sharing, so that in large installations we daisy chain the sensor units together, the processor together, to minimize the infrastructure and field wiring that needs to be installed. So how does it actually work? The secret is in the design of the cable, ultimately, where it looks like a standard coaxial cable, but the interconductor is loose and moves. So we send RF pulses, radio frequency pulses, down the cable. The energy that's reflected back to the processor is continually measured and analyzed. Vibrations that are transmitted into the fence and hence into the cable change the location of the center conductor relative to the outer conductor. And that creates a change in the amount of reflections observed by the system. And then the algorithms run and determine if the change in reflections is representative of a true alarm or not. And in a general terminology, how to simply describe this system, we would say it's an RF-based time domain reflectometry-based system. So now we'll just visualize what the system is doing whenever it detects an alarm. In the left-hand panel, we have a real-time monitoring tool, something that the technician would look at when installing and testing the system. And then obviously on the right, we see a camera view. So we're basically going to see a standard alarm being generated, and we're looking at the response at one particular point along the cable. Person engages with the fence. We see the response on the chart, and we see an alarm being registered. So that was pretty straightforward. The line went up, we registered an alarm. So what's going on behind the scenes, so to speak, to make that happen? There's numerous detection criterion that need to be met for that alarm to be declared. First of all, there's a threshold on the disturbance signal that's measured. And unless the signal goes above that threshold, nothing whatsoever is further processed. And it just so happens in that trace that we measured, we're just barely hitting the threshold in a couple of spots, but we are hitting it, so that's registering. Second, time is divided into time slices, for want of a better word, which is configurable, what that time slice is. It's set here for 1 second. Now we must see energy over a defined number of these time slices to create an alarm, and in this case it's set up for 3. So we must see a response in at least 3 of the time slices. Furthermore, those responses must be within a certain overall time frame, which is called the alarm window, which is set here for 10 seconds for demonstration purposes. Typically, this would be 30 or even potentially 60 seconds. And the longer you make it, the more sensitive the system is. Now, there are other parameters that are less visible. We're operating behind the scenes. There's frequency response adjustments that can be made. And there's an environmental rejection algorithm running that's comparing the responses along the length of the cable to minimize wind effects. Those aren't able to be visualized. So I'm showing them 4 primary criterion that the climb must meet. Actually, before we look at that, I just want to mention here that this processing and applying those detection criteria is done in multiple points simultaneously along the length of the cable, because this is a point locating system. So all this is happening simultaneously in along the full length of the cable. But we're just going to focus on one point. So what's it look like? Some disturbances that are rejected because they don't meet the criterion. So this is an example that would be representative of, say, wind noise. You know, we're shaking the fence a reasonable amount that would be indicative of you know, fairly decent wind. The signal is not going over the threshold. Nothing whatsoever is happening. You know, this is that input is completely rejected. Now we can look at a scenario where we partially meet the criterion. Say this could be representative of an animal bumping up against the fence or a kid's soccer ball. We have only we've only had one time slice active. So again, in this case, we're not declaring an alarm. Third case we're going to look at is the scenario where we get the necessary energy in terms of the disturbance level being active in 3 time slices, but we're going to see that it happens, the third one comes too late. So the system has timed out and it's not going to register, well, it's going to register the third one, but it's not going to declare an alarm. So again, the effect of the processing here, rejecting extraneous disturbances. Finally, just to show visually how we simulate a cut and what that looks like, we're going to do that right now. So we found a good screwdriver. Tapping with a screwdriver is a very effective, simple, and convenient way to simulate a fence cut. And when you do that, you get your 3 counts very quickly. And that's what a fence cut looks like. So I think that completes the demonstration and visualization of how the FlexZone system works. Now we'll move on to our second system that we'll demonstrate today, and that's our OmniTrax system. The OmniTrax system is a covert buried cable sensor that uses an RF, that generates an RF field around buried cables. This picture here, top right, is a favorite of mine because it shows a fresh installation of the OmniTrax cables where you can see the trench is still visible. After a few weeks or months, that will disappear, so it'll be completely covert. But you know, this is around a pharmaceutical campus. They have some nice grounds, some nice trees. This is where they want to put their perimeter line. There's really no other sensor that could be effective in this situation. That's a very unique attribute of the OmniTrax buried RF cable system, is that it's largely immune to vegetation, shrubs, and trees. So you can do this kind of thing where you couldn't really do that with hardly any other sensor, or virtually any other sensor that I can think of. So each of the electronic modules for the OmniTrax system covers up to 800 meters or 1/2 mile of coverage per processor. And for large systems, we can use multiple of the OmniTrax processors. We can connect the sensor cables together in the same way that I mentioned before for the FlexZone, so that they are not only acting as sensor cables, but they're communicating and sharing power from one box to the other. So the number of infrastructure points is minimized with the system. This is a visualization of the detection zone that exists above the OmniTrax buried cables. And again, this is also a point locating system, and it's accurate to 1 meter. Now, with the OmniTrax system, the signal that is observed is relatively straightforward. There isn't, you know, someone can cross this perimeter in a second, half a second, so you get a very straightforward signal. and you're more or less looking for a threshold crossing. So we'll do the same kind of visualization here, looking at the dynamic response of the system, and the threshold, not labeled, but this line in the middle. And we'll see the containment of the system, because that's one of the strong points of Senstar, or the OmniTrax system, is that you can be quite close to it, but not yet detect it. And that makes it obviously very convenient to use when you have limited perimeter distance. So just by the way, where the actual cables are located is highlighted here. And this is the plus or minus a foot location of the sensor cable. So the target is walking along the cables initially. Nothing is happening. There's no response. Cross, boom, get an alarm. Simple threshold crossing. Again, walking along, nothing happening. Crosses again, there's our alarm. So in terms of the prime parameters for it, that threshold is critical and is the primary adjustment that's made. There are some adjustments working in the background, again, some frequency control, but the prime thing that is selected is that threshold. Now, just to show another aspect of the system, again, focusing on the containment is with a car. We can drive a car close to those cables. We're 6-7 feet away, maybe, from the nearest cable with the automobile. Nothing happening on the system. So if you have a patrol road around your perimeter, you don't need that much clearance from the cables to not be getting a lot of nuisance alarms from your patrol vehicle. So that's a little description of the OmniTrax and a visualization of the kinds of response you get from it. Now we're going to switch gears, and we're going to go from one of our more covert type systems to our most overt in-your-face system, which is our X-field system. So the X-field system uses an array of wires oriented in the vertical domain. Here they are pictorially, and then here they are in a real-life photograph. For a set of wires, 2 wires are generating a low-frequency electric field, like low as in 8,000 hertz low, like extremely low, almost DC. 2 wires are generating the field. 2 or sometimes 3 wires are sensing a small charge that's induced on them by the active wires. And when an intruder comes into that zone depicted here, the amount of coupling from the active wires to the sense wires is changed, and that's the basis of the detection. The key benefits of this system are, one, that you can array the wires in quite a high array, up to 24 feet high or 7.3 meters. And that makes a very, very tough barrier to cross with any kind of normal intrusion methods. Because of the height and also because of the close containment of the detection zone, this system has been, for decades now, a recommended sensor for the U.S. Nuclear Regulatory Commission Regulatory Guide 5.44 for perimeter intrusion detection systems. So, and it has been established and become very popular in the industry of protecting all things nuclear, essentially. Power plants, used material, even military grade material. If there's nuclear material in North America, it's probably got the Senstar X-field system around it. Another attribute of the X-field system is that the wires, even though the voltage that the system works at it's not threatening and not harmful at all, those insulators and the wires look pretty scary to an intruder who doesn't necessarily know that the voltage is low and non-harmful. So they tend to want to keep a distance from that. Now, because we have an array of wires, active wires, sensed wires, we can make a lot of different measurements. So we can measure this disturbance level, this change in essentially the capacitance between the wires in multiple different places, typically, well, 4 normally. So when an intruder comes close to this array of wires, we don't just get one signal like we saw with the OmniTrax, we get 4 different signals. So, so we're able to do a form of pattern recognition, essentially. We don't just look for a simple disturbance, we look for the pattern of disturbance that matches the intrusion type. So for instance, if the intruder is going to go through the upper part of the system, either on some kind of bridging mechanism, or he's energetic and enough to leap through the wires, you'll get a pattern that looks like this, where the upper wires have the largest signal, and the lower wires, indicated by the color coding, get less of a signal. So this becomes a certain pattern that can be recognized. So, similarly, if the intrusion attempt is near the lower wires, you get a different pattern, where the low wires have the greatest number of signal on them. We take advantage of this, and we establish what we call profiles or patterns, so that depending for each point of intrusion through the system, potential point of intrusion through the system, we establish a certain pattern that must be seen. Which wires are going to go, which signals are going to go high, which should stay low to represent the pattern. And actually, so it involves, for each pattern, a total of 8 thresholds, 4 patterns, 32 thresholds. So this is a different kettle of fish from, again, the OmniTrax being the most distinct from this, where there was only really 1 threshold to worry about. Here we have the 32, and this requires a very systematic and disciplined approach to get all these thresholds straightened, done correctly. But when you do that, you have a very effective system that rejects most extraneous inputs. So we are going to just look visually, what that looks like. Intruder approaches. We see some signal. He's quite close to the wires. We see some signal. He's going closer, and we're going to even get a little bit of a pop-up, but nothing that would probably meet our thresholds. But now when we go in and do even a partial intrusion, just a part of the body, we see a dramatic response that would trigger the profile thresholds that we're looking for the upper. And then if we go lower, we get a very distinct pattern, completely different pattern, and again would trigger the profile pattern that we've set up for the low intrusion. So just a little bit of a visualization of the type of signals that we can pick up with the X field, and a little bit of an insight into how we threshold the system to get optimum discrimination between real and extraneous intrusions. So I think that's all on the X field. Now we'll move on to our Senstar LM100 system, which is a combination perimeter intrusion detection system and an intelligent lighting solution. So in the luminaires that you can see best in this picture, there's an accelerometer in the head and an LED lighting element in the luminaire. The accelerometer provides the detection, and so this system is also point locating, in this case to the luminaire. And the lighting solution is designed to work optimally with perimeter cameras to give a focused lighting pattern and a uniform lighting pattern where you need it in the perimeter to pick up any activity that's happening there. One of the critical aspects of the system is that the lighting is programmable. It's not simply just on or off, it's programmable through various levels. And that enables, first of all, flexibility in lighting so that in the daytime it's off, in the nighttime it's on, and in night you can have a steady background level and then the potential to bright up the light, in response to actions that would give you a deterrent effect. So we're going to demonstrate that lighting behavior. So in the demonstration that you'll see, we have a scene, and it's viewed with two cameras. Daylight camera on the left, thermal camera on the right. The LM100 is set to provide a low-level illumination, steady baseline. And we have on the thermal camera our Symphony video analytics running, and they're going to detect, using the outdoor analytic, the intruder approaching and getting close to the fence. Then, when the intruder actually engages with the fence and the LM100 has detected them, sorry, I forgot to mention something. The detection by the video analytics will send a command to the LM100 to increase the light level, so that then the camera can get the best viewing potential and for recognition of who it is, that's there. Then, when the intruder actually engages with the fence, that'll be detected by the LM100, reported to Symphony. Symphony will in turn send back to the LM100 a command to start the lights to be flashing. And that creates a very distinct deterrent effect. And the intruder runs away, which is really the best possible scenario at the end of the day, that really nothing bad has happened because you've deterred the intrusion. So let's just look at that scenario, how that plays out. The lights are on at a fairly low level. Intruder comes in. Detected by the video analytics momentarily. The lights bright up. Now he engages with the fence. He's detected. You get that flashing effect. And through the videos, through looking at it on our screen, you don't really get the full benefit of what that flashing looks like at night when you're startled by it and it comes on all of a sudden. It's disorienting and very disturbing, and is a true deterrent. So I think that is the end of the demonstrations. We thank you for watching. We have time for questions.
Yeah, no, that was great. I think I even learned an extra thing or two about S.I.T.E. We do have some questions that came in. Your fence test area has many sensor cables on it. Do any of the various technologies being tested interfere with one another?
Yeah, good question. The short answer is no, and the slightly longer answer is that none of the fence sensors are actively transmitting signals. Any signal that they use is contained within the cable, so they don't interfere with each other. And they're all fairly small and light, so they don't stiffen the fence in any way or change its behavior to intrusion attempts.
Okay, and for FlexZone, the question's what's the maximum fence height?
On a good quality fence with a single contiguous fabric, not broken into two pieces, our spec is 14 feet or 4.3 meters.
Okay, and how well does OmniTrax detect over time once shrubs and trees have grown in?
Short answer is very well. The OmniTrax has this unique property of being largely not affected whatsoever by vegetation. And the only slight asterisk there is if you have very thick vegetation and it becomes very wet, and then you have a high wind, you have kind of the worst case scenario. That can induce some observable signals into the system, but other than that, all the vegetation and trees are virtually invisible to the system.
Okay, another question about the buried sensors. Is there any way to install this with a soft construction?
Soft construction?
I assume they're meaning without an extensive holes or that being dug in.
Well, The minimum you need is one narrow trench. The OmniTrax cables, for instance, can be installed at various separations and down to as close together. The two cables can be 4 inches or 10 centimeters apart. So that minimizes the installation to one trench. And then similarly for fiber, that's really a single cable solution. So you would need just one trench. And if you have a lot of perimeter to do, and depending on your nature of the area, sometimes the cables can be plowed in. I would say that's probably most particularly true for the fiber patrol cable, because you could install it in long length. So that's what we can say about that.
Okay. How easy is it to fix cables, whether copper or fiber solutions?
That's a very good question. So it depends. So the two extremes I would say are FlexZone, which one that was demoed, and our fiber patrol fence sensor, which we didn't demo, but we talked about in the tour. The FlexZone is extremely easy. What I like to say is, give me a jackknife or even a kitchen knife and some old electrical tape, I'll fix that FlexZone cable. And if that's all you have handy, at 2 a.m., you can do it. The fiber patrol, it's a little different. The fiber patrol any repairs to the cable need to be done with a fusion splicer. So you're not repairing that right away with a roll of tape and a kitchen knife. You're waiting until the next day when your fusion splicer guy can show up and do it. The one thing with the fiber patrol is that we have the cut immune configuration where we use the two sensors to go around sites, count clockwise and counterclockwise. So the impact of a single cut is minimized. You lose some number of meters right at the cut location, but by and large, your perimeter is still intact until that fusion splicer guy shows up.
Okay, and can any of these products be used for concrete walls?
We have two ways of handling that. One, the most direct way is using the fiber patrol system, where we have characterized an installation technique by mounting the fiber patrol cable at the top corner or corners of the wall, either one side or both. And it becomes touch sensitive, but it becomes very difficult to get over that wall, without having some body part or some part of your climbing aid, rope, ladder, whatever, touching either one or the other of the cables. The other more generic and more intrusive solution is to put something on top of the wall, like some small topper with some barbed wire, 3 rows of barbed wire, or a razor ribbon if that's compatible with your environment. The other thing is sometimes the scenario is such that a microwave can be made to work, but that depends on the amount of clearance you have from vegetation and just what the wall looks like. So that's kind of the generic 3 ways we would look at walls. Not that, of course, video analytics is, I should mention that as well. I mean, sometimes, video analytics with a good camera could be your best option for a wall.
Right. Okay, I think we have time for one more question. Is the fiber single mode or multi-mode type?
Single mode. So our current generation fiber solutions work with single mode cable. That's our fiber patrol FP1150 for long range applications, and the fiber patrol FP400 for the shorter range applications. Both use single mode. We have an older generation system that is now close to, well, it is on its retirement watch as we speak. That's our IntelliFiber system. That actually did use a multi-mode fiber cable.
Okay, that's great. I think that kind of covers the questions for now. So if anyone has any other questions that come through, either you've probably got Stuart and I's contact details, or send them through your local RSM, and we can get some answers to you as soon as possible. Anything else you want to close up with?
No, other than just to thank you and thank our listeners for tuning in, and hope you enjoyed it. Thank you.
Thank you. Bye for now.